Start recording. Just make sure our output. All right. All right. Getting into it. Cool. So today's going to be more about sort of manipulating data, taking two data sources, and putting them together, and sort of doing some neat things that you can get. Like you can get GIS to calculate some interesting sort of geographic things and put it into a table for you, and then display it on a map. One way to do this, so right now we've been using, let me see, data. We've been using these little cylinder things that have the .gdb. This is a file GeoDatabase, and this is essentially a wrapper that holds a bunch of different data, right? It could be a table, like an Excel table, the sort of file that draws the shape of the states or the counties or whatever. And so that that's why when we click through these, we get, and we're like, oh, okay, we have the U.S. and we have states, counties, cities, etc. So these have been nicely prepackaged for us. But oftentimes when you're going and you download data from the Census Bureau or from someplace online, it's not going to come in that form. It's going to come, often you might get a shape file and you might have a table or something. Or you might get a shape file, like say you want to do something that has to do with Maryland. We don't have a Maryland file GeoDatabase here, but we can go find a shape file of Maryland. And then say we also have a bunch of interesting statistics we want to do with, say, Maryland counties or Maryland cities. And we have that info. We can't just sort of slap them both into GIS and it will draw it, but with a few steps we can. We can actually take data that was not prepackaged together and combine it and draw it on a map. And that's something that's the main draw to GIS, right? You have data and you want to put it on a map, and GIS will let you do that pretty easily. So the first way to start doing that is actually not in ArcMap. So we're in ArcMap right now. What we want to do is open something called Arc Catalog, and this allows us to do. This should be opening. This allows us to sort of take this data, put it all together into a GeoDatabase to make it much easier to put up on a map, right? So what we're going to do here, we're going to open our catalog, and what it has you do is sort of it should have your folder connections sort of in memory already, so you just you want to go find, it tells you to go find the Chapter4, right? So, I've done this, so I'm just going to save over what I've done. Actually, I'm just going to delete it, and we'll remake it, or I'll rename it, actually. That's maybe the... All right, it didn't like me renaming that, so... but we just right-click Chapter4, go to New, and then File GeoDatabase. And then we get a new blank sort of folder that we can take here. So I'm going to do Chapter4 class edition, although it just looks like classed, so I'm just going to do class. And now you have this here. It's just empty, right? It doesn't have anything in it. So what we can do is right-click it again and go to Import. And you want to go to feature class. So say if you have multiple things you want to bring in, like multiple shape files, you would go to feature class multiple. If you just have one, then you just go to single, right? It's pretty simple. So we we have two pieces of data we want to import that say we've downloaded from the census. Should pop up. And you just click this folder because input features. This is what you want. This is where you want to go look for stuff. And you want to go to this Mariposa County. Okay, yeah, we'll change the color scheme so you'll leave me alone. This Mariposa County has 3 files in it. 2 of them have the .shp, which is the .shape file. This is like the old classic file format that Esri came up with like in the 80s or early 90s, I think. And it's still kicking around. You'll see it all the time. And this is a table file. This is just an Excel file. So you go to so then you just click add, right? And this will bring it in, give it some time, and that's all you gotta do. You just hit OK. And now when we click on our thing, it's thinking. Now we have our shape files in here, or our shape files in here. Okay, yeah. And now, so say you want to now you want to bring in, like, you have data on, say this is Mariposa County. We want to bring in that data. So usually it's probably going to be in a table form. So you just go to import table, right? It's pretty simple. Now, this is where you'll run into a problem. When I did this earlier, it wouldn't let me do it. And if you're following along right now trying to do it, you might get an error. Has anyone got up to this point yet? No. So you'll get to this point, and what you need to do if you get an error is you need to install 2007. This is sort of an annoying thing I didn't know, but if you don't have like Office 2007 installed, GIS freaks out. Like I have the I've got like 2016 Office on my computer, and it didn't have these drivers, and so ArcGIS freaked out at me. It wouldn't let me import this table. So if you get an error that it won't let you import this table or whatever, just go to the internet and just Google 2007 Office System Drivers. It'll take you to the Microsoft website. It's like a 2-second install. Yes.
Should I do that on the virtual machine or on like my Mac OS?
Virtual machine. Yes. Because that's where the drivers are missing, is in the virtual machine. So, yeah, I'm sure I'll get emails about this week, and so but if you guys run into issues, you know what to do. But after these are installed, you can just go to boom. All right, so I'm going to step back. So we're in the data import. We go to we want input rows. We find the data we want. In this case, it has 2 different Excel sheets that we could import. The one you want is the one with the $sign. And you sort of get all this stuff. Does it want a nice name for it? Yes, it does. So we can call the data census data, so that's what this is. And it should bring all of that into the same GeoDatabase. There we go. So now we have 3 things in our GeoDatabase. We've sort of brought data from different sources together, and we can start messing around with it. So what we can do, and this is, you can go to this preview tab. Let's see if it's going to freak out. It's definitely freaking out. You can sort of see what these things are. Okay, so this is, I'm not entirely sure what this is, but you can look at look at these different things. Okay, so these are census tracts. Tracts are like smaller than a neighborhood, probably bigger than a city block. It sort of depends on population density. But so you could preview stuff and sort of look. Okay, so this is what this looks like. You can even preview the sort of data that's in your thing. Just make sure everything came in okay. If you download stuff from the Census Bureau or from Tiger, which is like another place to get government data, you can go over to description, and it might have some metadata like a code book or other interesting things. Yeah, so this has information stuff. So this is the Tiger line files, shape files, yada yada yada. Might have some interesting stuff in there. But so at this point, I think we're pretty much done. We just want to change these things to which one goes to what? Okay, so this one, the co-USUB 10, we're just going to name cities because it's the outlines of different sort of municipalities that are all in this area. And then the second one is tracks. And then this is census tract data. And that way, we name it stuff that we can understand, right? And you can sort of copy and paste these things. Like if you need to duplicate it, you can just copy paste cities. That'll work. Copy, and then boom, you can paste something in it. It's giving me an error because it's like there's something in here already named cities, so I'm going to name it cities 1. Like, yeah, that's fine. And you can remove stuff like this too. So it's pretty straightforward. You guys have probably seen this before. Depending on how big your data is, you might need to compress it. Like if you needed to upload it to the internet or try to email it to someone, you can compress it, and you would do that by going to Administration, Compress, and then if you need to uncompress it, you could uncompress it. Use case in this class is not very high, but later down the road you might run into this, and just be aware that it's an option. Okay, so we're good to go. We can go ahead and close out of this. We don't need it anymore. And we can open back up ArcMap. And sort of the last page, 151, on this 4.2 tutorial tells us to sort of draw this map. So what we can do is go up to Add Data. And so just navigate to wherever our GeoDatabase is, and we have all three of our things in here, and I can just click. You can drag them all and add them. So this is what we end up with. Wants this one to be blue. It wants us to label stuff, yada, yada, yada. So it basically just wants to sort of add all the data that we just made, sort of hollow it out, give it some thicker outlines, and then we're going to be using this map for for the rest of the sort of tutorial in the book. Questions at this point? It's pretty straightforward. If you have issues building a geodatabase, refer back to these first couple of tutorials. But right now, so if we look at this tracks shapefile, we want to look at the data that's in it. It's got some stuff. Yeah, I mean, so we have like an area. This Allen to 10 is a square meterage thing. We've got a bunch of like just sort of code name stuff in it, but it doesn't have any interesting data in it, right? Like there's no census data attached yet. It's just all this stuff. And so what we're gonna do is join the census track data onto it, but right now, like we don't need all this, and so we can just start trashing a bunch of these fields. So you can just go to right click and go to delete field, and you do this for 7 fields. They're all listed in the book. But this is something, it's certainly not necessary, but it does, like when you are super crowded, to first up, you don't delete GeoID 10, that's the important one. But as you start working like with more and more data, having a clean data set is like very nice. It just makes things much more clearer, and you can. It's just a nice like quality of life thing you can do, is to sort of just go and like knock out all the useless junk from your data file. Cool. So like I said, this GeoID 10 is what we're interested in here. So what these numbers are. So I just sorted ascending. What they are is, if we select one, boom, these are tracts. So each tract has its own unique code assigned by the Census Bureau, or at least, lots of different organizations will assign different codes, and so you just sort of have to figure out which code you want. Does your data have census codes? Does it have USDA codes or something? It might have, just sort of depends. But so you can see, well, you can't. I don't know if you guys can. You can't see this because it's too small. But if we go to here, we want to also sort of sending. You'll see this is like 401 ... 01. So this is our census tract data table, and then in our tract shapefile, when we look at our GeoID 10, and you'll see here, this is actually called GeoID 2. It's the same code. This is something you will have to. This is where code books come into handy, so that where you've downloaded the shapefile from will let you know what all these codes are, and where you got your census data from will do the same thing. So you just have to make sure, okay, this is the same code. They have called it something different, but I'm going to join on it. But for our track shapefile, you'll see it says 0401, which, does anyone know what a string is versus like a number? Do you want to explain what it is? What is it?
It's kind of hard to explain. It's just like text. It can't be used.
Yeah, you can't add it like. It's treating it like letters or something. Like it's you can't add this number, right? The computer does not read this as a number that you can do math with. It's just reading it as a tag, essentially. Like this could be anything, right? It could be or it could be A, B, C, D, E, F, G, right? But this number, this is something that the computer can do math with. Like you could add and subtract with this, but you can't. The computer can't compute between these two because there's not. It doesn't. It for all it can tell, it's not the same thing. So you'll run into this issue, and this is like the biggest bane in like data management and cleaning and joining. is sometimes people store it in string format, like string in a string, and sometimes they store it in a number. And like, I don't know why, I don't. It's just it's obnoxious. But it's also because it happens. It's super important, and something like you will probably come back to if you ever have to work with a lot of data. Because this is not a thing that is isolated to ArcGIS. This is something that you do working with any data. But this is how you solve that problem in GIS. So we'll see. Let's see. So since we want to add our tracked data to our tracks shapefile, we are going to want to change this, right? This field. So I want to deselect. And to do that, we go up to this little button here in the top left corner to bring down some options, and we go to Add Field, and we're going to call it, I think, GeoID10 number. And we're going to choose type, and we're going to choose double. Double lets us have like 15 integers long. It can be up to 15 integers, which is fine for what we need it for. And so once we have it here, we're going to go to the it's definitely field calculator, I think. We're going to go to field calculator, and you'll see here it's I know it's really small. So this is GeoID10 num equals. So that's what we're working with. This is the GeoID10 num column, and we want to make it equal to that string that we looked at before. So that's right here, GeoID10. We just double click it, it brings it down, and now it will drop. This is called a leading zero, and so this will drop the leading zeros, and now we have a number that we can take, and hopefully we can get these two data sources to talk to each other. But before we join, it wants us to add just a few other things. So say we want to get some ratios on here. So like we have. Oh no, we don't want it here. We want it here. So this is the data we're interested in putting on our map, right? It has median income, it has total pop, and then it has population by different ethnicity groups, and then median income by those groups as well. So what we might want to do is add something like. What is this? It's we want to add. Let's see. Hold on. I'm getting ahead of myself. We might want to know the ratio of, say, Native American median income to white median income. And so to calculate that, we could just go in here and we could start doing what we just did, right? We could draw down our, let's see, we want Native American income divided by white income, and we could click OK, but there might be, if we look at Native American median income here, there's a lot of zeros. So what happens if you divide by 0? It's undefined quantity, right? You can't do it. So what you have to do is sort of select. This is where getting to know your data is really important, because that can be a problem, right? So what we want to do to sort of get around that is, again, we want to select by attribute, and we want, let's see, white, or I guess we're dividing by not Native American income, but we're dividing by white income, median income. And I mean, and so this is if we knew this data set better, maybe there's a Native American reservation that's caught off here, and so then there might not be white income for there, and so we do find that there is one tract at least that does have a 0. So if we're dividing by 0, again, boom, we can't do that. So we want to. Let's see. Sorry, select by attribute. And we want white median income, and we want it to be greater than 0. And what this will do, is we see right here where it was 0, we're not going to see that, and that's because this is I don't know what this place is, but there's only 17 people in this tract. And you'll get this with census tracts because it's such a small grouping. Some tracts are much smaller than others. So this one, there's one that's 500 people, but then there's one that's 5,000 people. So there's sort of a big range. And so this one is particularly small, has 17 people. So that's why we're getting a bunch of zeros across here. So now that we've selected some of it, we can just go to field calculator and do the thing that we were talking about. So we're going to do Native American income divided by white income, and it'll give us that ratio. And so you'll see there's a whole new list of numbers down here. If we go down to this one, this has remained null, which is what we want. Because you can't divide that anyway, so it's it sort of drops out, and you could do this you could just keep doing this and get other things, or calculate other variables essentially. You can do a lot of, like, say in some cases your data might not have a total population field. So you can add all the different subpopulations that it gives you. You can add them together. So you could do add field, and we could do tot pop double, and then we could do, let's see, field calculator, and then we could just go and we could do like white pop, native pop, Hispanic pop, and we could just add all this stuff together, and that would create a total population for us. So this is where field calculator can come in really handy. Questions at this point? I know it's sort of flying, but it will hopefully make sense where we're going eventually with this. So now that we have these two data sources able to talk to each other, we can actually do the process of joining them together. So we want to right-click tracks and go to joins and relates and click join. So if we're interested in joining data to whatever we want the data to join onto, that's the one we right-click. So we don't want to join data onto this one, and we don't want to join data onto this one. So that's, that might seem straightforward, but mistakes happen. So now we need to find. So you'll see number 1 and number 3 give us where what we're interested in joining on, and then this is what we want to join, right? So you might have multiple tables in here, so you make sure you want to select the table you're interested in the data for, and then you go here. So then we find we see that we have our GeoID 10 variable, which is this variable with the leading 0. So that's not the one we want. We want the GeoID 10 num, which is the one we created. And then we want to join that on this GeoID 2 variable. So after you do that, you just click OK, and we should have more data here. So we do. So here's our GeoID 10 num, and here's our GeoID 2. So this shows me that, okay, cool. So all this data that was previously in the census tract data is now here, and we can now we can take that census data that previously wasn't here and actually use it, right? So we could look at total population. We might want to do quantiles. That's what we like to do. And we can draw, now we can take this data and put it on a map. So, I mean, that's sort of that's what makes GIS cool. Like taking data from two places, putting it together, and then putting it on a map. Like that's why we use it, right? And just in, I've been talking for about a half hour, but that whole process you can do in about 5 minutes, right? So it can, once you learn how to do it, it's very quick and it's really neat. You can, if you have an idea, you can go download it and boom, put it on a map very quickly. So this is sort of like one of the central takeaways from this course. So and we'll be doing a lot of this. Like there's a lot of this joining data for the rest of the semester. So hopefully by the end it'll sort of become second nature. Cool. So now we just want to go back to our old map. Okay, so this is sort of what our old map looked like. We're going to save it as 4.5. Okay. And right now, I'm just going to go ahead and actually remove that join because we're going to add more data to our map here. So you can go to remove all joins, and now we can see we're back to our old boring data. So once we're here, we want to boom. So these are all shapes, obviously, and I think Dr. Gimple was talking on Monday. We might have interesting questions about the distance from, the distance from your polling place might affect your propensity to go vote, or your distance from something to something else might affect something, right? I mean, these are spatial questions, and so GIS allows us to sort of measure those distances. And one interesting measurement we can look at is what's called a centroid. So that would be the center of this sort of geographic unit. And this might give us an interesting measure of, certainly like if we're thinking about redistricting, which is the second sort of leg of this course next semester. One of the criteria for drawing political districts is compactness. And you might have you might have a shape like this, and you might have a shape like this. And this is a centroid. This is the center of this object, and this is the center of this object. And then you might be interested in the sort of distance to the perimeter, the edge of this object and this object. And then you would look at the variation, right? So variation is sort of the amount that data varies, right? So this has a lot of very small measurements because the centroid is very close to this edge, and it has some very large measurements because it goes all the way to the edge. So it's going to have a very big variation. But this is much more even, right? Can you guys see this? Actually, is a computer in the way? Okay. This has about the same to all the edges. And so this is going to have a much smaller variation. And so this might be one way we could measure compactness in political districts. Yeah.
Just out of curiosity, what for the exams coming up, and like what's going to be on this? Going to be more focused on this or a lecture? Like, are the readings that we're doing going to be on the exam?
It's going to be lecture. So this is only a lab portion to get you guys sort of hands-on experience working with spatial data, so that you have something to hang, like you have hooks to hang that sort of information on from lecture, right?
What about the readings that you have us do for Monday that are like from other people?
I'm pretty sure those will be touched on, but I'm not entirely sure. When is the exam? Not next week. The October 9th. That would be something to, I think, ask Dr. Gimple on a Monday, and I can reach out to him as well. In the past, the tests have mostly been, lecture material, like the sort of basics of spatial analysis, like near things are more similar than far things, right? Being, a basic tenet of that. But it also will have some aspects of the sort of readings that he's been having you do as well. So it's a vague answer because I don't know the exact content of it because I'm not writing it, but that's broadly, it's not this material, right? The way that you were evaluated on GIS is through the assignments. But any other questions? Okay, so the whole thing. So in order to actually do this measurement, we have to know what the centroid is, the center of this geometric shape, and GIS can do that for us. So, I didn't click on it; it's freaking out. So what we can do, one way we can do this is go, and we can create XY coordinate plane. And we want to use float, I believe, or double. And we want to add a Y. Double Y. So we have our X and our Y here. And so we've been using field calculator, and that's for doing calculations with numbers that are in our data set, like adding, subtracting, and stuff like that. But what we want to do now is go to calculate geometry and click yes. And you'll see X coordinate to the centroid. So I mean that's perfect. That's what we want. And boom, we get that, and we just can do the same thing for Y. But make sure you go ahead and select Y. You'll also see here, right? You could measure the area of the centroid. You measure the perimeter. But here we're just doing Y, or X and Y coordinates. So now you have centroid measurements for each tract in our data set. So, and now it wants us to rejoin our data. So again, we want to join on our numeric value. And okay, so now we've rejoined our data. We have centroid measurements, and we can take these values and now draw them on the map, right? And the way that we do that is actually a little like it's not the most straightforward way, but what we do is we just need to find our data. To go over here to the catalog, right? Oh no, if you hit the X button, you see it went away. This is one of the obnoxious. So if you accidentally remove catalog from the right side of your screen, like I do it all the time. You just go up to Windows and click catalog, and it comes back because it doesn't want you to. Yeah, it's silly. But so this Centroid data is in this tracks part, and so what we're going to want to do is we want to go to where is it? Oh, did I join it from the wrong side? Hold on. Oh, no, I just skipped a step. So what it wants us to do is actually open up this tracks thing, go to export, and this is just going to export the data to an Excel file or to whatever we want. In this case, we actually just want to save it back into our database. So we go to here. And here you want to select File and GeoDatabase tables. I've already done this on this computer, so it has defaulted to this, but it won't default to for you. So this is something that you'll have to make sure in the Save As File type you've clicked that. And then it just wants us to save it as tracked centroids. And it's going to ask you, do you want to add it to your new table or add it to your table of contents? So yeah, sure do. And this is now just the exact same table that is in here, right? So the reason we do this is because we can actually create, we can create like point data out of this, and you do that by, once you have your table over here, you just right-click it, and then go to Create Feature Class, and the only option in here is From XY Table. So, and what this will do is create points on the map of those XY coordinates that we generated earlier. And we want to navigate back to our GeoDatabase. So right now, it has defaulted me to a shape file. So I could export this to a shape file, and I could drag it over. But you can also, if you click it, go to File and Personal GeoDatabase, and all of a sudden it pops up these things. So you can save them as this. You can save it here. And this just wants us to name it, I think, tracked Census tracked centroids. But before we hit OK, we have to project our data as always. So, or give it actually not project it, but give it a coordinate system. So this is something that Dr. Gimple talked about, I think, last week, where you can have like a simple XY coordinate system, but geographers have come up with all sorts of different coordinate systems to measure stuff on maps, and so you have to make sure you're using the right system. And so what we can do is actually just take the coordinate system that tracks is using, and we can do that by selecting this, clicking this little world icon, and going to import. And then you just need to navigate to your GeoDatabase. So ours is here, and we just click. We just want to import. Yeah, definitely. It's from tracks, so we just click Add And at this point, it's taking the coordinate system from tracks, and it's going to generate, it'll generate these new points. So now we have the center of each of our shapes on the map. And again, this could be a way that we might now calculate something, or in the past we've seen how we did graduated objects. You know, you might make an object bigger for certain values, and I think that's probably what we're going to do now. Yeah. So it wants us to do, I think, total pop. Oh, we want quantities. Actually, what we want. I want to use our quantiles. And that gets us a population density map. But then we also want, what else does it want us to? Oh, sorry, I did it. Getting ahead of myself. It doesn't just, it wants actually a Hispanic population, and it wants it normalized to the total population. So this will give us a measure of density. And then that changes our map considerably. So then we can compare these across, right? So like these are very densely populated, and these are very sparsely populated, but we can compare across because we've normalized the data. And then what does it want us to put on? Oh, median income. So now we can click our new Centroid layer that we've created. We can go to quantities, go to median income, and actually we want graduated income. Here we might want, so you can change these the symbol ranges. So from like 2 to 10. Because 18 is enormous, and it's going to like wash out all these different little census tracts in here. So you might want to you can rein those in. We always want quantile. And then this gives us a way of displaying the data. And this might be a situation where we want to zoom in on the more densely populated area here, so we can actually see what the variation is here. So this is, I mean, again, just a further application of like joining all this data and different ways you can use GIS to calculate interesting things based on the sort of shapes on the map. Yeah. Questions at this point? I know we're moving fast, and this can be sort of dry, but again, it'll be up on YouTube hopefully later today. If you need to go back and sort of just see, wait, what did he do? Or if you, obviously I'm just following book, right? So, cool. All right. So, I can save that. And now we're actually going to open the last section here, which is 4.6. And I think this is Pittsburgh, Philly. Where is this? Rochester, New York. So this is, I believe, maps of, we can sort of do some zooming. These are patrol routes or car beats for Rochester Police. So if we can sort of see what that. Obviously, there's going to be some roads that we might make this map more useful. And then these are just businesses as they are distributed throughout the city. So I think something that Dr. Gimple has talked about is the sort of proximity to a liquor store or a bar often predicts crime. So maybe the police are interested in having tighter patrols around bars. I don't know. So this is something that one question that you could answer using GIS. So if we can sort of look at this. So this business file has just a bunch of businesses, right? And street addresses, etc. And this has other things. These aren't very interesting variables, but we can look at maybe how we could join them. Doesn't look like we have something we can join them on yet, but we do have this, which has our SIC code or something, or whatever this is. And so this is, these are hard to read, but these are designations. So 01 is agriculture, 011 is cash grain, 201 meat products, etc. So these are different designations for businesses. Logging, yeah, I mean, so the drugs. So different business codes, essentially. So right now, we don't really, if we look at our business sheet, we just have the SIC number here. We don't know what these numbers mean. So maybe we might need to add this data in to make this more useful, and I think that's what we do. So we right-click the business layer because that's what we want to join to. We go to join, and we want to join on the SIC code. So this should add. Okay, so now we have SIC code, and we have designations here. So this is now much easier for us to look and say, oh, okay, the business on 1780 East Avenue is non-classifiable. Okay, maybe that's not the best one. Okay, 24 karat in auto reconditioning. Okay, what could that be? Okay, it's designated as a car wash. So this makes this business data more usable, really, and it allows us to create a more targeted query. And so this is something. Going back to queries, if we wanted to, before we've filtered cities based on population. In this case, we're going to filter on business type. So what we want to do is, I think we want SIC description is what we want. And we want this to be equal to, the book says, eating places. So that's what, we just type it in here. We get this. Or we want it equal to, And say, what we didn't quite know how this was spelled. You can always click Get Unique Values and scroll down and find eating places here and double-click it and add it. But we also want drinking places. So, and this is where it's hard to see here, but these are wrapped in quotes, and that's really important. If you don't have the quotes, it will try to think you're giving it a number, and it's like, this isn't a number, and it'll kick out an error. So you make sure you put in quotes, because it will to tell it, hey, this is a string, expect a string. So if we just click OK, and we click Apply, boom, that filters out a lot of places. So now we only have eating and drinking places. And so now we can. So right now, so far we've done joins on data in tables, right? So we've done what maybe a data join or something. But we can also join stuff based on space on the map. So we can join data based on how these dots on the map and the lines on the map sort of overlap, or how close they are. We can create a variable out of that. So in this case, we're going to create a count of the number of eating and drinking places per police beat. And this would give us an idea, okay, so which beats are maybe stretched thin, or which have too easy a time, and we can sort of redraw the routes they can take around the city. So we want to click car beat, go to joins, and select join. And so right now we've been using this join attributes from table. But what we just want to click down to join data from another layer based on spatial location. And so this is another one of the really, really neat things GIS can do, is it can tell us distance or closeness, right? And what we want to make sure that we are joining data from the business layer. Again, that's the only option it's going to give us, but if you had other stuff, you might want to change that. And we're not going to actually change any of these things, but we could get a whole bunch of summary statistics here. We could get mins, we could get min, max, standard deviation, variance, sum, average. These are all maybe things that we might be interested in. We're not going to grab them right now, but we're going to export it to. It wants us to put it. Where does it want us to save it though? That's what. Chapter4 GeoDatabase. Yeah, it just wants to save us in here. Okay. So this is count. So we export, and now we have an interesting new layer file here, and we can draw on it like we can everything else. So we could do quantities. We could do graduated color for. Look, we have our variable here. If we open this up real quick, boom. It has summarized each of these 41 beats. It has counted based on space. It sort of looked at all the businesses and given us count data, and that's pretty cool. And so we can just draw. So we go to count and get some more interesting color or something, and all of a sudden we have we have new data on our map. So we can, here it wants us to do this. So then we have the number of the beat on the map. So I mean, this is another one of the really interesting things GIS can do. Is it can take these two data layers and generate a new thing that we might be interested in, and we can go from this to this very quickly, because if you're trying to give a presentation or try to convince someone or have show some data that you think is convincing, this is not very clear, right? But this is immediately much more clear. Obviously, if you had you would know the sort of what the darker colors meant in these cases. But yeah, so you can very quickly go get to where you're going. You guys get what I'm trying to say. But cool. Questions? So it's a lot of new stuff. I understand. If you have questions, let me know. That's pretty much all we have